Dr. Baliga here. This podcast is on chronochemotherapy and cardiotoxicity. I was stimulated to do this podcast after reading a terrific review titled Clocks, Cancer and Chronochemotherapy in Science magazine, authored by Dr. Aziz Sancar, MD, PhD, who is a Nobel laureate in chemistry and at the University of North Carolina. And his co-author is Dr. Russell Van Gelder, MD, who is chair of ophthalmology at University of Washington in Seattle. In a recent podcast on Yamanaka factors, I talked about methylation clocks and aging, particularly the Horvath clock. Other clocks are the Hannum clock and the Levine clock. But today, I'm going to speak on a different set of clocks, the mammalian circadian clock. We all know there's a circadian clock and there's a diurnal variation in our bodies. For example, cortisol is at the highest level in the morning and at much lower levels in the evening, reaching a nadir at 12 midnight. The circadian clocks are associated with jet lag, with sleep, and metabolic syndrome. In addition, when the circadian rhythm was disrupted in animal models such as the fruit flies, mice, and chipmunks, the loss of the circadian clock was associated with the worst chance of survival. And this is the basis for the hypothesis that circadian dysfunction leads to disease. In this fantastic review in Science, the authors review the current status of research on the effects of clock disruption on human health, particularly in carcinogenesis, and efforts to improve cancer therapy through precisely timed treatments or chronochemotherapy. And I would like to argue that maybe cardiotoxicity is a manifestation of disruptions in the clock. The mammalian circadian clock at a molecular level is composed of a time-delayed transcription translation feedback loop, or TTFL. This primary loop consists of a transcription of two genes, the cryptochrome gene and the period gene, and is driven by a heterodimer of clock and BMAL1. The cryptochrome period dimers translocate from the cytoplasm to the nucleus and inhibit the clock BMAL1 driven transcription from the E-box element. There is a secondary circadian loop which is driven by E-box driven transcription factor, which drives the expression of Rev-RB alpha and RORA, which modulate BMAL1 transcription. It has been argued that circadian regulated genes are critical in timing of cell division, and therefore it's possible that circadian dysfunction could contribute to dysregulation of cell division, which we all know is a hallmark of cancer. In an elegant paper in PNAS 2010, volume 107, pages 4890 to 4895, T.H. Kang et al. From Dr. Aziz Sankar's group have shown in breast cancer cell line disrupting the circadian control can alter the response to doxorubicin and cisplatin. Altering the circadian rhythm, they found, can alter the sensitivity or can result in tissue more resistant to DNA damage and response to chemotherapy. There appears to be a specific relationship in each cell type between DNA damaging agent and the specific molecular components of the clock mechanism. In addition, they conclude that these instances where the clock has an effect on the level of damage formation, the circadian clock strongly modulates DNA response pathways, DNA repair, DNA damage checkpoint apoptosis, and senescence. It appears that the circadian clock modulates the effect of carcinogens in a manner specific to two things: A, the carcinogen's mechanism of action, and B, its interface with a particular core clock protein. The circadian clock affects DNA damage checkpoints by two mechanisms: A, by the regulation of expression of checkpoint of cell cycle proteins, including P20, P21, and NO, which are involved in the G1 to S transition, and B, the interaction of clock proteins directly with checkpoint proteins to alter their activities. In this article, the authors argue that chronotherapy is the timing of drug delivery at the appropriate phase of the circadian rhythm to achieve optimal efficacy. The rationale for this approach is threefold. First, the efficacy of an agent may vary with time of day dependent on its mechanism of action. Secondly, the metabolism and the pharmacokinetics and pharmacodynamics of agents may vary with the circadian phase. And finally, the toxicity of agents may also vary with the time of the day. We all know cortisol levels are highest in the morning, and one would argue that prednisone-based chemotherapy regimens like CHOP and R-CHOP probably should have a higher dose of prednisone when given in the evenings. In fact, in animal studies, global repair of the DNA is low in the morning and is at a maximum in the evening. And as predicted, when mice are treated in the evening, they exhibit higher repair than those treated in the morning. On the whole, there is a paucity of data on the efficacy of chronochemotherapy, but some studies have suggested it may cause more harm. This is a challenge for cardio-oncologists, oncologists, clinical trialists to develop clinical trials which are targeted towards a strong circadian modulation. The next step would be to conduct and design clinical trials of rational chronochemotherapy, both at the bedside and at the bench, with possibly inducible pluripotent stem cells as a model. Encourage the listener to read the outstanding review article published in Science magazine, 2021, 1st of January, volume 371. It's high time we investigate the circadian clock with regards to cancer chemotherapy and cardiotoxicity.